Okay. It's about 11:33 now, so my point is we've had a lot of class time that's gone by, but you can tell that obviously is not my handwriting. Okay? We've had students come up here and write down their own examples and then go through this process and actually name these compounds. Okay? So what we see happening then, okay, is the idea that, okay, for tomorrow, your evaluation, there are no alcohols or acids on there. That will be for another time and another place. But some of you are concerned about this, and you're just getting all wrapped up about, oh my gosh, I got to remember all of this. But the content is there, okay? What we mean by this is, what is the name for one carbon compound? Methane. Okay? What is two carbons? Okay, keep going. Okay, keep going. Do we need to keep going?
Yes.
Okay, well, keep going. Okay, now, stop there, because some of the questions that you were asking earlier is, do we get a sheet of paper with the names of these compounds on there? And the answer to that was no. So you did a decent job for those of you who went through and named all of these. Okay?
Can we have that on the board tomorrow?
I'll give you two guesses, but you only get one.
Yes.
The answer is no. Okay? That was a wrong guess. All right. But my response to that is why?
Because I don't, I can't remember them in the order.
You can't remember these in the order.
But once you get to 5, it's just like normal. Yeah, but I don't even know those.
Well, you've got from now until tomorrow to get that done. We said alcohols and acids are not on tomorrow's evaluation. That's for another one. So the reason I wanted to leave this up here, okay, is what we perhaps struggle with the most in my estimation is isomers. Okay? So what would be the simplest way to make an isomer of this? So keep in mind, we already know that there's 6. This tells us how many more carbons are there.
2 more.
Okay? I hope we can do simple addition here.
Put it 1 to the...
Okay? So then how many hydrogens are in this compound?
18.
Okay? And you can count them if you want. Okay? 6, 7, 8. There's our 8. 3, 5, 8, 10, 11, 13, 15, and 3 more gives you 18. So this is an isomer of a straight chain called what? If you have C8H18 in a straight chain is just octane. This is an isomer of that octane. And how would you know that by its definition?
Because it has the same formula.
It's a different structure. Okay? Can we do a heptane isomer?
Yes.
Do what? Okay? Or, I'm sorry, we can leave that one on here, but then remember, I erased 2, so that means we got to put one somewhere else. On the top of, please stop that. Okay, you tell me when to stop.
Stop.
So right here? Okay. Now, what's the name of that compound? It's still hexane. 3,3 dimethyl hexane. Okay? Oops. Okay. We can't tell what the difference is. Okay. The example that we gave in class. Why is the symbol for iron Fe? Okay. It means it was derived from the Latin word. So you translate ferrous, Latin, into English, means iron. So a derivation means where it comes from. So the ferrous portion is derived from the Latin language. So this methane has a formula of CH what?
CH4.
CH4. So then if we put this in a box, that has a formula of not CH4, but CH what? So that term, this is a what group? So why is it called methyl? Because what is it derived from?
Methane.
It's derived from methane. So just like ferrous, the Latin term for iron, translated to English.
And if there's 3 of them, it'd be whatever it's called.
I know whatever it's called. I agree. Okay. So then what is another isomer that we could do? There's a lot of them. We're not going to go through all of them because we're just not going to take that much time. Because I don't want to just write things up here and then if you're not participating or answering that, if you don't know it today, you're probably not going to know it tomorrow.
How would you have it'd be 2 carbons, like, on top of that?
No, you just have to have two. You just have to have C8 and H18. So you have to have 2 more carbons. So you can put C.
But going back to a question we asked earlier, can we make a heptane molecule?
If we try hard enough.
Okay. How would we do that on this chain?
Put it under the.
Under what?
Or bend it. Bend it.
You want it here? That's not what I would guess, but now our longest continuous chain is 1, 2, 3, 4, 5, 6, 7. So we've got heptane now. Is there anything branching off of that heptane? Yes, a methyl group on which one?
3.
On the third one.
Wait, is it 3 or
4, sorry. I was looking at this. So can we just move this methyl group? Sure, let's go ahead and put it over here. 1, 2, 3, 4, 5, 6, 7. We still have heptane, but that methyl group is on which carbon now? It's on the third one. That's another isomer. All of them will have that same formula, but the structures will continually change. Okay? But don't do this. I've seen this before. Okay? Let's say, for instance, if we had just hexane, don't think you're going to do an isomer of that with an alkene. Is that possible? No, it is not, because you are changing the organic family. Because if you try to do that, okay, let's say, well, I want to do hexene. That must be an isomer because the structure's different, right? But what is not going to be the same? So in this case, 6 carbons, 14 hydrogens. So this one, please stop that.
Okay.
So then how many hydrogens would you have here?
12.
Okay, you only have 12. So that means you cannot make an isomer of an alkene from an alkane. Because what does ANE mean? It's a saturated alkane. What does ENE mean? Unsaturated alkene. It's a different organic family. Okay. So then this is pentanol. And if we have, I know these aren't going to be on here tomorrow, But if you really, really have a good understanding of this, what is the simplest way to make an isomer of this?
Put it one jar to the left. Was it one alcohol?
It's an alcohol
Put it one jar to the right. Put it on the side.
because are there any numbers in front of this? No. So we know that this means alcohol. This means that there's 5 carbons. This means that everything is single bonded. So if you really, really want to be specific, you can write what in front of here?
One.
Okay? So what might be an isomer of this?
2.
And how would you do that?
Just move it to the left.
Well, whatever it is that you were babbling about, I could not understand. And yes, so either someone did not pick up on what you were saying, because I sure didn't. Okay? Can we still do another isomer of that? Right. We can move it one more to the left. Now, you can't go to this one. Why is that?
Because then it switches to right.
Now you're going to have 2 pentanol again. And you can't put it here either, because then it's still the same as what it was over there. Because remember, this is in 3 dimensions. Okay? So the last thing I want to go over is, let's see here. So we got heptane. What is a halogen derivative? Okay, so where do you want this halogen derivative located?
Second.
Okay,
4.
okay, so if that's the case, what is that called?
Chloro.
I know, but the compound, sorry.
4-4 heptane.
Okay, we're mumbling again, sorry. Is it something that the rest of the group would like to hear? It's just a question. It's yes or no. Step outside. You don't need to stay here anymore.
What did I do?
Okay?